So I think we can get started. Almost 5 minutes past 10. So we'll go 5 minutes over, and I'll try to make sure we can leave some time for Q&A towards the end. So quick introduction about myself. My name is Mandeep Singh Sandhu. I'm product line manager at Palo Alto Networks. I look after App ID, SSL Decryption, and some of the PAN-OS infrastructure features. Today what we are talking about is what are some of the best practices for our customers to adopt SSL decryption, get away from the complexities, deal with some of the issues. So I've structured the presentation in a way where we'll do a quick poll, then we'll go through some of the recent things happening in the industry. Then we'll talk about decryption profile, then we talk about decryption policies, and then we talk about some of the challenges customers can face with SSL decryption. And we'll have some time for Q&A towards the end. Sounds good? Okay, let's get started. So a quick poll, quick raise of hands. So what are your plans for SSL decryption in the near future? So how many of here are in the option A? Okay, about 10 hands. Option B. Okay, just 2 people. I have a picture 8 slides down, by the way, that might relate to you somewhat. C. I'm curious about C. We have 3 to 4. Okay. D. Everybody, right? Awesome. This is why I love Europe. You guys do it. If I were to ask this question in US, it will probably the same number of hands for B. I lived in Europe for 7 years before moving to US, so I'm always biased a little bit. How about option E? Oh, thank God. Okay. How many here are doing forward proxy? Outbound? Most of us, okay. Inbound, anybody? Okay, that's not bad. Option C. Okay, still few people with GDPR and still doing C, interesting. Last one, option D. How many of you are doing that? How many of you have heard of that? Okay, you have. Anybody here, a quick raise of hands, who has 10 to 12 different devices for security, and there's something doing decryption and sending traffic those 2 devices? Anybody? Like a security stack, service chain? Okay. This is my favorite question. So for those of you who have no plans or maybe you struggled, what is keeping you away from SSL decrypt? Performance? Anybody worried about performance? Okay, 5 to 6 people. Legal issues? Okay, I can't fix those, by the way, but good to know. Time and effort, because we have infinite time in the world and infinite resources. And last but not least, applications breaking. Okay. There's one more. Is anybody not planning to do decryption because of GDPR? Great. I think we can skip through 10 slides now based on this poll. So talking of GDPR, like if you take the entire GDPR standard and if you up-level it at a very high level, it achieves 3 things. It achieves 3 things for users. It essentially gives users more control of their data. So it gives them privacy and data protection. That's number 1. Number 2 is it makes the enterprises and organization, technology companies, have more responsibility of the data they own. This includes even companies like us, but this definitely includes the likes of Google, Facebook, and even enterprises. What do you do with that data? And last but not least, transparency. If there is a breach, that ever happens in one of these companies, they have to report that publicly. They cannot withhold that information. So that's, we all know this, right? I mean, you guys have probably read this standard multiple times. And what does SSL Decrypt give you? SSL Decrypt gives you the foundation that we believe is the right philosophy for getting network security. It gives you complete visibility. It reduces the attack surface, because once you have complete visibility, you can go and build policies. It prevents known threats, and it also helps you prevent the unknown threats. Because if you do not have decryption and you have the wildfire profiles attached, you're not really picking out any files from the TLS traffic and sending them up to wildfire. However, if you do have SSL Decrypt on, you're actually picking out files and sending it to wildfire, converting unknown threats to known threats. Now let's look at some of the recent trends. So a few things happened in the last few years. And when I say last few years, you can think of starting from 2015. One thing that happened around 2015 is that HTTP 2 became a standard. HTTP 1.1 had been around for a really long time. And Google created a protocol called Speedy, which became HTTP 2. They took it to IETF, gave performance benefits to anyone who owns an HTTP 2 server, made things faster for the end user. Once that happened, something interesting happened, because HTTP 2 can only be delivered inside SSL. No browser supports clear text HTTP 2. And most servers, the standard says there could be clear text HTTP 2, but most implementations are based inside SSL or TLS. The other thing that has happened in the last 2 to 3 years is the adoption of TLS 1.3, it becoming a standard. And as you can see, based on these statistics, about close to 20% of the websites today use TLS 1.3. One thing that also happened while these things were happening is that there's a company by the name of Let's Encrypt, where it becomes super simple to get certificates for your website. So all these trends together, specifically HTTP 2 and Let's Encrypt, led to a rise in the amount of SSL traffic. Now TLS 1.3 does some interesting things. It essentially takes the TLS 1.2 protocol, makes it more faster, more secure, more efficient. And the way it does that is it shortens the handshake. It takes 60 cipher suites which were available in 1.2, and it simplifies that down to 5. If you have less choices, you're less likely to make a mistake, which improves security. And it does a lot of things for user privacy, which has ramifications for the enterprise security industry. HTTP 2, on the other hand, is very different from HTTP 1.1. So if you look at this picture, it's basically like there's a comparison of 2 different types of candy. HTTP 2, what it can do is it can take a single TCP socket, TCP session, and within the same TCP session, it can put different applications. So if you use Google Chrome, for instance, or any browser for that matter, and you're going to Gmail, and in a second tab you have Google Drive open, and on the third tab you have YouTube, where you're watching cat videos. If you have these 3 open at the same time, and if you go to developer mode inside Google Chrome, you will actually see that all these 3 tabs are pinned to the same TCP session. Now that makes things challenging, right? That could be like, okay, so if it's the same TCP session, what's the application? What's the URL category, right? So, and none of that problem is a problem unless you decrypt, by the way. Because if you're not decrypting, it's just a TLS connection. So what we did in 9.0, just to level set here what we can do for these recent industry trends, is that we came out with HTTP 2 inspection, built natively into our firewalls. What it does is that as soon as you turn on SSL decryption on the firewall, in forward proxy or in any of the supported modes, we automatically go and apply policy, your existing policy, on all these different sessions. So even if you have 3 tabs open for Google Drive, Gmail, and YouTube, and if you download something malicious in Google Drive, we will kill only that session while your YouTube video and your Gmail will continue to work. And the way we do it is we do it completely transparently. You don't have to go and read the RFC of HTTP2 to understand how it works, unless you don't have a life like me and you like reading RFCs, you can do that, but it's completely natively built into the product. And the reason I talk about it here is it's important to understand like how we are evolving ourselves as the internet is evolving with these protocols. Now, when it comes to TLS 1.3, there's a few things that we can do today. So first of all, just some data point here. HTTP2 became a standard in 2015, and it's 2019 now. Every site that runs HTTP2 also runs HTTP 1.1. We suppose a similar trend will happen with TLS 1.3. It's not like TLS 1.2 will cease to exist by next year or overnight. So they'll continue to work. So today, if you turn on decryption, we downgrade the connection to 1.2 without breaking it, without reducing security either. We don't do all that. However, we are looking at it from a technology point of view, and very soon, hopefully by next Ignite, we'll have an answer and a slide as awesome for TLS 1.3 as we have for HTTP 2. But the main thing to understand for 1.3 is it can be decrypted. It's not one of those protocols where you cannot do anything about it. The other thing to understand is anyone who's doing passive decryption where they were collecting data and then using your server's private key to go back and look into it, that's not going to be possible anymore with 1.3. However, inline decryption is still possible. The other thing about here, about TLS 1.3 is there's a lot of news about encrypted SNI. So encrypted SNI is still a draft. It has not become a standard. Some of the CDNs implemented it, and they've done some recent experiments and recent research where a lot of things broke with encrypted SNI, even for the CDNs. There is a way to negotiate it out if you remove the DNS request, if you can proxy the DNS connection before the encrypted SNI. So there are ways to basically work around that, and encrypted SNI is still not a reality. And we are closely monitoring that. I wanted to kind of get that out of the way in the beginning so that when we are going through some of the best practices, you guys are not thinking about that all the time. So we all know this, that most of the traffic on the internet today is encrypted. This is a statistic from Google Chrome, back from April this year. And as you can see, close to like 80% of the traffic is encrypted now. And some of the reasons for this rise in encrypted traffic is what we just discussed. HTTP2, Let's Encrypt, and so forth and so on. The other thing that also has risen along with the amount of encrypted traffic is the number of phishing attacks. And it's pretty interesting that there's a correlation between these two statistics, because encryption is a double-edged sword, right? It gives benefits to the end users in terms of privacy, but it also makes the attacker's job a lot easier because he knows that not everybody is going to go look inside TLS connection. Not everybody has the capabilities to decrypt. So I can just use SSL for command and control. I can use SSL for dropping something malicious into an enterprise, or harvesting credentials, which still remains the one way of attacking. So what we can do about it is this, where we can basically have no plans for SSL decryption, which is fine, but then it's also accepting the fact that ignorance is bliss. If you don't know what's going on, it's easy to say that there is nothing going on. Or you can embrace reality. So what I have here is actually a traffic report where I'm showing all the threats that are seen inside decrypted traffic. You can actually run this on your firewalls. So if you write a custom report where you put a flag that show me all the threats which are critical or high, and the session is a decrypted session, you will get interesting data. The reason I bring it up here is sometimes it's very important for network administrators to show the value of turning on SSL decryption to the execs. Like, what does this get me? Why should I go and do this? Or why should I give you money to go invest into achieving this, be it headcount, be it other things? And this could be a good way to explain that. So let's look at some of the best practices now that we kind of set some context and stage around this. So what I wanted to give here as an example was something we did within Palo Alto Networks. So we turned on SSL decryption across our entire company, across all our offices, all different locations over the last, I think, a period of about a year. And this is a cookbook that we went through, which kind of worked for us. Just to give you an idea of scale, today we are about 7,000 people at Palo Alto Networks, spread across the world. Our biggest offices are, of course, in US, in Santa Clara, but we have a very big office in Amsterdam here. We also have big offices in APAC, in Singapore, and Japan. So the approach that we took was that the first thing that you want to do is you want to do a controlled rollout. You don't want to go and implement SSL decryption carte blanche for everyone, because that may shorten your career span. Let me put it that way. So you first want to go through the approval process. This involves a lot of discussion with your legal counterparts in your company on what are the risks here, if there are any, and what should be considered as a right legal approach. The second piece of this, which is very important, is identifying users. My favorite users, if I was to do this, was to pick developers, because they are the hardest people to satisfy. They will never be happy. They're extremely intelligent. And if you can make it work for them, I think you will be able to make it work for other people. They will have a lot of scripts that will run inside SSL. They will have a lot of non-standard SSL traffic. So starting with that helps. Also, it is important to kind of have a diverse user set, not just go with developers and only fix it for them. What we did at Palo Alto Networks is that people volunteered. When we started this project, there were some people from R&D, developers, product managers. There were people from marketing. And there were people from other departments. Once you identify your user set, you establish PKI, then you start writing policies, and then you see what happens, what works, what does not work. Once you've run this controlled experiment, you replicate it across different locations, and you continue expanding it. So how do you start? How do you lay the foundation? So the first thing that I want to talk about laying the foundation is, please do this. Like when you go back home today, well, not home, but after Ignite finishes this week, and when you go back to your offices, please go block quick. Nothing's going to break, because Google Chrome will automatically start using TCP. The best way to go about blocking quick, we have two options. You can either use the app ID we have called Quick, but a better approach is just to block port UDP 443. If you block UDP 443, no other application uses it, unless you have one of those developers who built an application 10 years ago to use UDP on 443. Hopefully you don't. Please do this, because even if you're not decrypting and you're not doing this, you're losing visibility into a lot of traffic. We can identify pretty much every single Google application or Facebook application without decryption at a higher level. We can tell you that someone's going to Gmail versus someone's going to YouTube versus someone's going to Google Drive. With Quick, we can't do that. With Quick, everything looks like Quick. So even if you're not planning to implement decryption, you should still do that. If you're planning to implement decryption, you definitely should do this. Now, having said that, it does not mean that this will never become a protocol which will become more popular. We are not saying that. I think from a technology point of view, it's an amazing idea. What the industry or the likes of Google and IETF are thinking about it is that the internet of the future will be running on UDP instead of TCP, which is a big statement to make. So it's still going through its motions. It's not a standard yet. It's still an RFC. It's still a draft, and we are closely monitoring it. But for now, we recommend customers that security is more important, so please do this. OK, so once you do that, the next thing you have to do is you have two options. You can either create a self-signed certificate, or you can import your enterprise-level PKI. Most likely you'll do the latter. You'll import your enterprise level certs. However, if you do create a self-signed cert, you have the options to create RSA or ECDSA certs. You can create both. ECDSA will give you better performance than RSA and more security because the key size is smaller. And we can pick whichever one to use based on the destination server. Once you've done that, the other important thing to understand is the concept of forward trust and forward untrust certificate. So you'll have two types. You'll have the forward trust certificate, which is this. Sorry, I clicked twice, I guess. So this essentially is the impersonated certificate for all the trusted sites that a user is going to, which are legitimate sites, which are like Gmail, Facebook, Office 365, Twitter, whatnot. And you would want the user experience to be very smooth. You don't want them to get a lot of pop-ups. And then you also have something called forward untrust certificate, which is basically if they're going to an untrusted site, you do want to warn them that you're going to an untrusted site. And you want to use different certificates for that. You don't want to use the same certificate for both purposes. Now your trusted root cert will go and sit inside the trusted root store on Windows or on your MacBooks or whatever you're using. And the untrusted one, you do not want to install the untrust certificate on that store because you actually do want your users to get a warning if they're going to an untrusted site. Okay? So always remember that. Now, how do you, once you either created these certificates or imported them, what is the best way to integrate with existing PKIs? So the best way to go about it is that you can use your forward trust as the subordinate CA to your corporate root CA. The reason we recommend customers to do this is because the amount of work you'll have to go through is minimal. Most of your endpoints already will have this root cert imported on the endpoints, so you don't have to go through that extra step of pushing this out unless you're creating self-signed certificates. If you are doing that and you have to go through that work, it's important to remember that for all those browsers, the trusted CS store is the Windows store. There is one browser missing there, which is my favorite. How many of here use Firefox? Okay. So you guys like living on the bleeding edge and maybe some memory leaks. But if you do use Firefox, the store for Firefox is built into the browser. There's a knob that you can turn on for Firefox where it can default to a Windows store. Firefox also is one of an interesting browsers that starts implementing any technology before any other browser. You can install this cert across your endpoints using one of these methods. There may be more. This is what we came up with. You can use global protect. You can use Active Directory cert services. If you're using the likes of MacBooks, like RIT is, you can use Jamf, Centrify, Alteris. You can use MDMs. There's an open source tool called SaltStack that you can use to also push these out. Now, once you have done that, the next step is Decryption Profile. So what are the security outcomes for Decryption Profile? I wanted to talk about for every one of the best practices, what is the value of doing that best practices? It's important to understand why you're doing that rather than just go and do this. So security profiles give you three things at a very high level. They protect users from going to bad sites. There's multiple ways of protecting users from going to bad sites. You can use URL filtering. You can use other techniques, but also one of the techniques. It also gives you a lot of control on what cipher suites should be negotiated, what TLS version should be there. And last but not least, it also helps you tune application behavior. And I'll show you how. Before I go into the next slides, a quick question. How many of you here have used HTTP header insertion that we released in 8.1? 2, 3 hands? OK. And I'll tell you why I asked that. So how do you protect users from going to bad sites? So this is what our recommendation is for the best practice. It has changed from last year a little bit, because last year I think we also had this thing clicked. I don't know if this works, but let me try again. Oops, yeah. So the reason I have marked this as unchecked is because a lot of applications have started using client authentication. And I don't think we should tell our customers to completely block those, because if applications break, users will complain and you will not really implement decryption. And I'll come back to that option later. But what's important is to block all those things, the unexpired certificates, untrusted issuers, versions, cipher suites. You can also block these depending upon what you want your security posture to be. This is if the system is running out of memory. The other thing you can do is having granular control on ciphers. So please don't allow any TLS version less than 1.2. Hopefully you're already doing that. We only recommend you allowing ECDHE and AESL, ECDHE as a key exchange algorithm, and these as the encryption algorithms, and these as the authentication. Okay, then let's talk about tuning application behavior or controlling it, and I have 2 slides around that. So first is the no decryption portion of the SSL decryption profile. So it's a little interesting because we have no decryption inside something called SSL decryption. What this helps you do is that even if you're not doing SSL decrypt, you can still create this decryption profile and put it on your decryption policy. This is the #1 way of blocking anonymizers. And I've tested this multiple times with XVPN or Siphon or UltraSurf or Tor. If you just do that, I think you block at least 50 to 60% of their traffic. You have to do other things too to completely block it, but this comes in pretty handy. So that's why I'm talking about, like, this alone can give you a lot of advantages. And blocking anonymizer is just one thing it will do, but it will also give you, stop your users from going to bad sites, even without having to decrypt. Very powerful. This is gonna change when TLS 1.3 happens. Can anybody tell me why? Nobody? Zakaria? So the certs will already be verified for the server. It's not that. The reason it won't work with 1.3 is the certificate is encrypted. So if the certificate is encrypted, you can't really do this, which means you need to decrypt to look at the cert. And that's a reality we have to embrace. But guess what? 80% of the sites, it'll still work with today. So use it while it lasts. 20% of sites are using 1.3, 80% are still using 1.2. I was asking about HTTP header insertion. The reason I asked about that is HTTP header insertion, when we built it, it was in 8.1. Then we built a capability in 9.0 called HTTP 2.0, which is supporting that. However, there's only so much time and resources. We do not support inserting HTTP headers inside HTTP 2 streams. So if you're using HTTP header insertion 8.1 and you're planning to upgrade to 9.0, and you are using HTTP header insertion to differentiate between Gmail personal and Gmail corporate, or you are using Office 365 only my tenant capability, then when you upgrade to 9.0, please check this flag, specifically for Google, not for Office 365. Office 365 is still not using HTTP 2, by the way. And the reason is that this will downgrade the connection to 1.1 only for that specific decryption policy, so that you can continue to use HTTP header insertion. When we created HTTP 2 as a capability, we do not support it for some features like header insertion, like clientless VPN. So we wanted to give users flexibility where they can still use those capabilities by downgrading it to 1.1. The users will not have any visibility into this. It will be completely transparent to the users. So that's about decryption profile. The next thing, which is the most important thing to talk about here, is decryption policy. The reason I need to look at my phone is they don't have a timer here. So decryption policy, what are goals, some of the goals of decryption policy? What are the security outcomes? So you want to hit these outcomes. You want to have compliance. You want to balance security and privacy. And you also want to balance security and performance. And how do you do that? And to understand that, we need to talk about URL filtering and what we have done in 9.0. So in 9.0, we came out with multi-URL category support. So for every URL, we can have up to 4 URL categories. What we also did, we added, because now we can have multi-URL category, we also added risk per URL. So we can identify a URL as high risk, medium risk, or low risk, depending upon our own intelligence driven from PanDB on if this specific domain, top-level domain, has seen malicious activity or not. If it has seen malicious activity in the last 30 days, it's high. If it has seen it in the last 60 days, it's medium, and if not, it's low. There are, however, some exceptions, some hard rules where some types of websites will always be considered medium risk. An example of that is file sharing sites. Dropbox, Box, Office, Google Drive, OneDrive, we will never mark them as low risk. They will always be medium risk. And the reason behind that is the likelihood of a malicious file being on one of those sites is very high. Now, what happens when you take these two things? When you take the multi-category and combine it with risk? So we even extended this concept to custom URL category. So far today, before 9.0, when you write a custom URL category, you write a bunch of URLs and you say, this is my custom URL category. So we've improved that to basically now say that you can make something called custom URL category match, where you can combine these two aspects. So you can have blogs, and you can combine risk with that. So you can say blogs per high risk or high risk blog sites. You can even combine categories like 2 different categories to create a new category. We don't have a category for medicinal marijuana, but you can actually combine medical and one more category I forgot to combine to make that category. But combining risk with an existing category will help you do some interesting things in SSL decryption, and I'll talk about why. So we all know about the sensitive URL categories, correct? I suppose most of you here are not decrypting these. Anybody here decrypting these on the top? You're decrypting all of them? Interesting. We should catch up after we finish. So the other thing to look into this is that if you are not decrypting these because of legal compliance reasons, you can now combine it with risk to make this decision a little different. You may not want to decrypt these categories, but you may be able to convince your CIO or CISO that if someone's going to a high-risk financial site or a high-risk shopping site, we should actually decrypt this traffic. So the way you do that is you create a custom URL match category by combining 2 different categories. Example here is that I've created something called low-risk shopping. There's no such thing as low-risk shopping, by the way. Like, you always lose money. Happens all the time. But what I mean here is that things like Amazon or, I don't know, a European shopping site, I guess MediaMarkt or Bol.com, the likelihood of something malicious going on there is very low. So you can be okay to actually not decrypt those, but you want to decrypt everything else, because someone could be using one of those shopping sites to harvest credit cards. So how do you put this in policy? So one example is that balancing compliance with security, which we just talked about. You created that custom URL category. Now you can actually, in your no decrypt policy, you can basically say, well, I don't want to decrypt financial services, government, health and medicine, legal, but also low-risk shopping. Another way you can use this is to balance performance with security. You can basically say, Any Game of Thrones fans here? Game of Thrones? If you're a Game of Thrones fan and if you're in Barcelona, you should go to Girona. They actually did a lot of scenes in Girona, by the way. Girona, I don't know what's the right pronunciation. The reason I talk about Game of Thrones here is, like, you will not really get a lot of security benefit if you're decrypting someone's Game of Thrones traffic. First of all, like, you shouldn't be watching Game of Thrones while you're at work, but maybe you are. Do you really want to put all the processing power of the firewall into decrypting Netflix or HBO Now or one of these other streaming services? You may want to do that, but really, other than giving you visibility and reporting into how much bandwidth you're wasting on streaming, it wouldn't really give you any security value. So you may be okay to say, okay, you know what? I want the most value out of my investment. I don't want to decrypt anything which is streaming related or which is low risk streaming. So you'll be able to take out the likes of Netflix, but anything which is a streaming site and which is malicious, you'll still be able to protect your users from going to those sites. Okay, so this is how you write policy with URL filtering, with 9.0, with risk-based URL categorization. It helps you write more intelligent policies. It helps you write the strike balance across performance and security. So a good start now, another way of looking at it would be, okay, you have your no decrypt rule on the top, and a lot of customers, and there were a few hands that went up in the morning when I asked, like, how many of you are okay about starting decryption? We are not saying that go back from Ignite on Monday and turn on SSL decryption for everything. We were always suggesting that first, don't decrypt, then create your some users who don't want to be decrypted and decrypt everything else. Now, instead of that, you can do, don't decrypt your sensitive categories. Just go and decrypt high risk or medium risk. You will cover all file sharing activity between high risk and medium risk. You will cover all malicious sites that you can't completely outright block. You'll be able to decrypt. You'll be able to get experience, get confidence. And once you get enough confidence, you can move to this final goal where you're decrypting everything else. So the risk-based URL categorization now gives you a very good starting point. You can, in fact, even start with high risk, to be honest. If you just want to show the value to your exec staff, just start with high-risk URLs, run that traffic report, and then come back and turn it on for high risk and medium risk. And then at one point, get here, where you're decrypting everything except those exceptions. We'll talk about decrypt bypass as part of troubleshooting on what do you mean by decrypt bypass, okay? So another thing I want to talk about before we move into the challenges and troubleshooting is, how many of you here have heard of DOH? D-O-H, okay. D-O-T and D-O-H are DNS over HTTPS and DNS over TLS, respectively. New inventions, of course, from our favorite company, Google and Mozilla. Turned on inside Firefox, by the way. What it does is it basically takes your DNS traffic and it puts it inside SSL. DOH puts it inside regular TLS traffic on port 443. And it becomes a problem. It solves also a problem where, you know, it gives more privacy to your users and doesn't, and kind of to some degree stops the internet service provider from selling you targeted advertisements. But for enterprises, it also makes you blind for that DNS traffic. So our recommendation is that how you can block this DOH traffic is you can either use our app ID, which will block all publicly known DOH resolvers, or you can decrypt this traffic, and then definitely you can block DOH. DOT is a little easier to handle because it uses a standard port 853. So if you want to block DOT, you can just block 853. In either cases, your browser will downgrade to using standard DNS. Will not really literally brick your users, by the way. We get a lot of questions on this, so we wanted to talk about that. So what are some of the challenges? So generally, when users turn on, our customers turn on SSL decryption, few things go wrong, right? First is decryption breaks, applications break, and the reason applications break are high-level 3 reasons. One is mutual authentication, incomplete certificate chain, certificate pinning. Incomplete certificate chain doesn't happen that often anymore because companies have fixed that. But very common is mutual auth and certificate pinning. So how do you fix these problems, or how do you deal with them? So for mutual authentication is a concept where generally when you go to a server, the server is authenticating, you're authenticating the server if it is legitimate. But in some cases, the server may also want to authenticate the client. Now this never happens on normal web browsing traffic because it's just impossible to do it there. Because now a server will have to remember identity of about 7 billion people that live on this planet. However, it is very easy to do when you're not using a browser, but when you're using a thick client. Sky for Business, for instance. You have many other clients on your mobile devices that can do this, where the client is also authenticating itself. Now, if you have that thing clicked, it will automatically block these sessions. However, if you don't have that click, it will continue to work, but in the logs, you'll be able to go and see that there's a session and reason where the failure reason was cert validation. This is when you know that, okay, these connections are failing because of mutual authentication, and you can go and remediate these. We're going to make this a lot simpler very soon. I completely acknowledge that troubleshooting decryption is very time consuming, and we are actively working on something which will make this a lot simpler for all our customers. So what happens if you don't have that clicked is that we will add this to the SSL Exclude Cache. This is different from Exclude List. If it's added to Exclude Cache the first time, we will remember it, and any subsequent connections will not break. They will continue to work because there's a cache entry which says bypass decryption for this. And this is the command to see that. Incomplete certificate chains. So about 2% of the top 140,000 domains still have incomplete certificate chains. These are sites. These are not the most common sites, by the way. You will not have these problems from the most popular sites. However, if you do have this click, which you will always have, which is a best practice, when you go to a site with an incomplete certificate chain, you will get this error. To remediate this, a lot of browsers have started fixing these themselves. So the likes of Chrome, Firefox, they fix this problem themselves. If you still run into a situation where this is not fixed, you can fix it like this by clicking the trusted root CA for the subordinate CA. However, if this is a non-sanctioned application, please do not allow traffic. And the likelihood of this happening for a very popular application is pretty much zero. It's only sites where the admins are somewhat lazy and you run into this problem. However, what is more common and happens all the time is this. And this is different from mutual authentication. So SSL pinning, there were two types of pinning back in the day. When I say back in the day, things changed about a year back. There was SSL certificate pinning, where a company that has created an application, so instance your mobile phones or your browsers, when you have a fat client, they tell the application that only create a connection if you see a certificate from Google, from Apple, or from a specific entity. If you see anything outside of that, don't connect, just break it. There used to be another pinning called HPKP, which was pinning implemented through the browser, where there was an idea that you could do this for websites. HPKP got obsoleted about a year back, so don't have to worry about that. This is still there, and this is becoming more common. This is becoming more common as more and more applications have, you have the mobile versions and on tablets. It's become super common since Android 7 Plus. So please use Apple, like I do, for better security and privacy. I'm just kidding. Android 7 Plus, anything that uses Android 7 Plus, you'll have this problem because all those applications are pinned. So you will not be able to decrypt them. The only option is to bypass them. Technically, it's impossible to do decryption if the endpoint is essentially telling that I only expect a certificate that is served to me by Apple or Google. And it's not just a problem for Palo Alto Networks. This is a problem across the entire industry. What we are focusing a lot of our efforts on is how we help customers get to a state where they get security without breaking all these applications and where you can selectively make a decision. Okay, last but not least, the decryption exclude list. So this has existed on our firewall for a very long time. We actually made some improvements to the exclude list recently, where in PAN-OS 8.0 and onwards, you can actually go and see this list, and you can actually go and edit this list. You can remove entries, you can add entries. The way exclude list works is that whenever we create a new app ID, we do this research if this application will work with decryption. If we find out it will not work, we push a content update to update the list that for this new app ID that we're releasing, decryption breaks it, so please exclude it. You can actually also add to this list based on your own research if you have applications within your enterprise environment that are breaking after decryption. Now there's a distinction between using this versus using a no decrypt policy. You can also create a custom URL category and say, okay, all these URLs that I have in my environment, I don't want to decrypt. When you do it with exclude list, you don't get as much control as you get when you do it with policy. Because when you do it with policy, you can do source dest IP, you can do all those match columns. When it is an exclude list, everything is excluded from decrypting. So use this only for the most popular applications and for anything that you have created within your environment, where in some cases you want to decrypt and in some cases you don't. Use the policy to do a no decrypt. Okay, last section, I'll quickly run through some of the useful CLI commands. Feel free to take pictures. Just kind of a deep dive on what can help you troubleshoot while you're adopting these best practices. There's a really good CLI command that can show you all the statistics for all the certificates that are being used across the firewall, what versions and ciphers are being negotiated. There's another CLI command that helps you look at the exclude cache on what are all the different applications that are being populated into the exclude cache, because some of them are using mutual authentication. This can be viewed and cleared through CLI. If you have run into a really big problem and you want to quickly disable SSL decryption, hopefully you don't run into that. You can actually run a command on the entire firewall. But it's troubleshooting. Don't forget to unrun the command after you fix the problem. And call to action. We have everything documented as best practices. Please go read that. For customers who are thinking of adopting SSL decrypt, also look at best practices assessment tool to understand how far you need to go, how far you have come along, to constantly measure yourself. There's a lab we have in this Ignite for deep dive on SSL decryption best practices. I encourage you to go and try that and give us feedback. And there are more resources listed here. Best practices for decryption, URL filtering. We will talk about this also in another session that I do on Friday at 8 a.m. in the morning. Save the best for last. It's going to be the best session for Ignite. It's about best practices for securing your internet gateway. And that is a session where we'll talk about everything. How you use URL filtering, how you use app ID, and how do you get there faster. Thank you. I think we still have a few minutes for questions. Yes?
Looking at the experience you guys made when you are rolling out the SSL decryption within Palo Alto, you give us some experience you had with most common application, Office 365, SAP, some of the business applications.
Yeah, so the question is like when we were implementing SSL decryption at Palo Alto Networks, what are some of the experiences that we went through? What worked, what did not work? What applications broke, what did not break? So we ran into problems, of course. It's not like it was a completely smooth transition. Some of the applications that were affected, a lot of our mobile applications, like any app that you use from a mobile phone, even from an iPhone, a lot of those were not working. And we had to work with our IT as part of R&D to go figure out which one of those have to be excluded from decryption. I think that was the exercise that took probably the most amount of time. But once we got to know what works, what doesn't work, we got to a stable state. A lot of these were actually developer applications also, or in-house applications, some of them. Some of them we were able to go back and change the application to make it work. Some of them are applications like WhatsApp with which you can't really do much. You don't have an option. Some of them were covered by Exclude List. Some of them were discoveries where we had to add things. So no short answer, but yeah, that was part of the process. Any other question? Yeah. Separate question for a separate discussion, not for this. But yeah, we can do that. Yes? 1.5? No, 1.3. Yeah.
1.3, I'm not sure how we can deal with secluded list like these. Yeah, it's an excluded list of domains where we don't want to do SSL decryption for because of SSL pinning. So SSL pinning with TLS 1.3 is a big problem.
So the question is, how will we deal with TLS 1.3 and SSL pinning? And the answer is the same way you deal with it in TLS 1.2. Because TLS 1.3 will still have something called SNI. It's not going to be encrypted. Not today. Not maybe in a year from now. So if you have access to the SNI, you'll be able to exclude it. You'll be able to write policies. You'll be able to do pretty much the same thing that you do with 1.2 today. The biggest difference with 1.3 will be we'll not have access to a clear text server certificate, which means the no decrypt piece of decryption profile you'll not be able to apply. Okay? Is there a stable version of 9.0 that is out there today? Yes. The stable version of 9.0, which is preferred version, is 9.04, which I think is about 3 to 4 weeks old now. And to give you another data point, I think about 11% of our customers are using 9.0 today on their firewalls. 9.0 is the one that supports HTTP version 2, that is correct. For anything prior to 9.0, we downgrade HTTP 2 to HTTP 1.1. So you'll still be able to get all the visibility, we just downgrade it.
Have you seen any large BYOD environments in a customer network where they've implemented encryption without MDM, and what methodology or procedure they've used to get a cert on the endpoint?
So the question is, any large deployments where we have seen a customer deploy BYOD without using MDM? I don't know. I don't have, but I can try to find that for you. I'm sure there must be somebody who has done that. Yeah. So the question is, what is the frequency of the update to the SSL exclude list? So the frequency is that anytime we update new apps once a month, we definitely go and add to that list. But we are trying to get to a model where we start updating that list more often, outside of the new app ID list. As a general measure, like if we find out that these applications do not work with SSL decryption, we want to start updating exclude list more often. So you'll see more updates coming out sooner. Okay, last question, and then I think we are out of time.
I asked you before, how do we get the presentation?
How do you get the presentation?
Also my question.
Okay, also your question? I'll have to ask the Ignite, I don't know where's the marketing people, but I think these will be made available after the conference. If not, then just send me an email, I guess. Okay, thank you so much.